Good evening, students. Okay, yesterday I was just talking about the test generation strategies. Okay, so before beginning with the test generation strategies, okay, just we will re-look into the diagram now again for the test generation strategies. Okay, for I have already told you for any type of test generation strategies, the initial point will be referring to your requirements document. Okay, you have to refer to the requirements document. Based on the requirements, okay, you are going to decide upon the strategy in order to generate test generation algorithm. Okay, you have many strategies like finite state machines. You are supposed to make use of state charts, petri nets, and logical specifications, timed input output automata, and sometimes you will basically use the code to generate test generation algorithms. Okay. If you see the diagram over here, even though strategies might be different over here, the outcome of all these strategies is going to be the uh, test generation algorithm, wherein you will come up with a one type of algorithm which defines or which will give you the test cases. Okay, if you look into this, the outcome of all the algorithms is going to be the test cases which are helpful for testing my software. Okay, if you see over here, sometimes whenever you are using the code, along with the code you will also make use of a runtime results which will be fed to the test generation algorithm in order to generate the test cases. Okay, in order to generate the test cases, in turn these test cases are fed to the code in order to test the program's behavior. Okay, this is how the test generation strategies will result in a test generation algorithm which will be giving the test cases. In turn, will make use of these test cases to check the observed behavior of the program. Okay, this is in short we'll be studying, and in this particular diagram what you are supposed to know is different types of test generation strategies. Fine. After that, we have just looked into the types of software testing. Okay, they have come up with four types of classification. Basically, based on the source of test generation, what is going to be the source for generating the test cases? That is the category number one. Okay, category number two is going to be the life cycle phase, that is software development life cycle phase, in which I'm going to carry out the testing process. Okay, third one is going to be the goal of testing activity. What is exactly the objective of the testing process? And the last classification is going to be the characteristics of the artifact and the test. Artifact and the test I've already told you yesterday. It artifact can be a code, it can be a component, it can be a module, it can be the program as the whole. All these come under artifact. In general, I'm referring it as artifact under test. Based on these four things, I'm going to have the types of testing. Let us look into these things. Okay, source of test generation, that is I'm considering the only first category C1. If the artifact is requirements, okay, if the source of test generation is requirements, then the technique that I'm going to use is black box testing. Black box testing, basically it will be looking into the functionality of the software rather than focusing on the internal implementation details. How I have implemented, that is not my concern. Okay, what are the functionalities that I'm supposed to test? Okay, you are supposed to look into that, and you are checking the functionalities of the software. That testing process I call it as black box testing. Okay, so whenever the artifact or the source of test generation is requirements, I'm referring the requirements, that time the technique is going to be the black box testing. Suppose the source of test generation is code itself, the program that is written by you, then the technique that I am deriving is white box testing. It is in contrast with the black box testing, where I'm concerned more with the internal implementation details rather than upon the functionalities. Okay, and here if you look into this example, if you remember two or three, it is more than enough. You are don't by heart these examples. Okay, what is more important is to know about the techniques based on the source of test generation. That is important. Which technique you will arrive at whenever the source of test generation is requirement and the code. Okay, here if you remember one or two, it is more than enough. In this first category, whenever the requirement is the source of test generation, I'm making use of cause effect graphs, equivalence partitioning, partition testing, so on. And in this, we will be studying about cause effect graphs, equivalence partitioning in the further sessions. Okay. After that, I have something called the source of test generation as code. Okay. And I'll be deriving at white box testing. And the example for this is data flow testing. We'll be studying that also. And adequacy, assessment, structural testing, part testing, all these things will be covered in the next forthcoming sessions. After that, if the source of test generation is requirements, along with the requirements, I'm also considering the code for deriving the test cases. Okay, then the combination of black box and white box testing techniques I'm using. Okay, it's a see, if you look out for these two things, you will infer that. Okay, whenever I'm making use of these two things, requirements as well as the code, then I have to make the hybrid combination of black box testing as well as white box testing. Okay, suppose if the source of test generation is the mathematical specification of your program, then I have to go for model based specification, wherein I'm going to model the requirements using finite state machines or state charts. Okay, so the technique that I'll be using is model based specification, in which requirements will be modeled in the form of finite state machines. That's why the example they have given is state chart testing and finite state machine testing. Okay, after that, if the source of test generation is component interface, okay, then the technique used will be interface testing. Here basically I am concentrating on the interfaces that I am using in order to connect two modules in my software. Okay, so we will be not looking into this much, but we will be studying these things in detail, black box testing and white box testing, in the forthcoming sessions. Okay, second category, as I was explaining, it is based on the life cycle phase in which I am carrying out my testing process. As you already know, okay, for any software development life cycle, there are common stages involved. First is always you will gather the requirements, you will analyze the requirements, then you will come up with the design process. Based on the design or the system architecture that you have discovered, you will program. Okay, you will program in order to get the solution for those requirements. How can I implement those requirements in the form of the code based on the design that you have arrived at? Okay, you will come up with the coding part, then you will analyze that. Once you have analyzed it, you will test that whatever implementation that you have done. After carrying out the testing process, you will deliver the product. Okay, maintenance. After delivering, the last stage is going to be the maintenance. So there are so many phases involved in the software development life cycle. It is common thing I'm telling you. In the software engineering subject, you have studied so many cycles like that. One is waterfall model you have studied, spiral model you have studied, like that. Okay, I will be considering one a specific phase in which I am going to carry out this testing process. Based on that phase, I will come up with certain technique. Okay, this is the second category. Suppose the phase in which I am going to carry out the testing process is coding. In coding phase, I am going to conduct the software testing. Then which is that technique I am going to use? That is unit testing. Okay, that is incremental wise. I will take up one functionality and I will try to implement that functionality. Once I have implemented by writing the code, I will be testing that particular specific unit by writing the test cases. Okay, or unit testing is smallest entity testing. Okay, you are considering only small piece and you are testing it. That I call it as unit testing. Okay, apart from that, integration. Okay, it is one of the phases. Again, integration means you have already developed the code, modules you have developed, and you have integrated as a one single unit. Okay, before that, okay, during the integration phase, if I'm carrying out the testing process, then the technique that I will be using is integration testing. It basically focuses on integration of the modules. During the integration of the modules, which are the test cases that I'm going to design, and I'm going to carry out the execution of those things. Okay, that is what I call it as a integration testing. After that, system integration. System as a whole, if I've integrated, after integration of all the modules, I will arrive at one system as a whole, one big unit. Okay, that if I'm trying to test that particular system, then the technique that I will be using is system testing. After that, I have already mentioned about this phase, maintenance phase. This is after the delivery of your product to the particular client. Okay, next phase is going to be the maintenance. Okay, that is which technique that I will be using? Regression testing. Okay, even after making certain changes, like you have already delivered a product to the client. After that, there will be some changes in the technology or updates in the technology. Suppose client tell you to accommodate those updates in your particular product delivered by you to that client. Okay. After what you will do pertaining to the request made by the client, you will induce those changes or updates of a technology in your software, and you will try to test it whether it is acting as per the new changes or not. Okay, that testing I refer it as regression testing. Okay, even though I induce the changes, but it has to work fine. Okay, that is what I call it as a regression testing. Basically, it is done in the maintenance phase of your software development life cycle. After delivery of the product, what comes next is the maintenance. Okay, already system has been installed in the client place. What you will be doing is you will be maintaining that product. Okay, you cannot say that I have delivered a product to you, then my work is done. No, after that maintenance phase, you have to go through this phase for a certain period of time. Okay, for a certain period of time. If the client request is please accommodate the changes as per the technology updates, then you have to install those updates in your particular software product and check and test whether it is functioning normally as earlier, even though after the inclusion of new technology updates. Such testing, I refer it as regression testing. After that, post system or pre-release. Okay, post system means post delivery of the product. Pre-release means before releasing of your product. Okay, in both the phases, the technique that I will be using is beta testing. And there is one more called alpha testing also, which is called acceptance testing. These things we'll be studying in the next sessions. Okay, in depth. Beta testing, alpha testing, regression testing, system testing. All these testing techniques we'll be studying in detail in the further chapters. Okay, you have to remember these techniques. That's it. In which phase, which of the technique will be used. Okay, this is based on the second category, which focuses on the phases or stage of the software development life cycle in which testing is being carried out. Okay, you have to remember that. After that, third category is based on the objective of the testing activity. Okay, see, in general scenario also, if you are going or if you are performing any new activity, there should be some objective for that task. Without goal or objective, you are not supposed to carry out any work. Okay, just for the sake of doing, if you are doing, you will not be successful. Okay, in general terms I'm talking about now. I'm linking the same thing over here also. Suppose I'm carrying out any testing activity, there should be some objective with respect to that testing activity. Suppose the goal here is advertised features. That is, I'm advertising the new features to my client. Or if I am focusing more upon the security aspect, okay, and if I am focusing upon the invalid inputs, okay, or some vulnerabilities or errors in the graphical user interface. then what are the techniques that I will be using? If I'm dealing with the features, if my objective is to just advertise the new features of my product, then I have to carry out the functionality testing. If the security is the main aspect, main objective of my testing process, then security testing. After that, if I'm focusing more upon the invalid inputs, I'm dealing with only the input domain, okay, I'll just try to give out the invalid inputs to my software product and I want to test it out, whether it works fine or not, or whether I'm handling it properly or not, even in spite of giving the invalid inputs. Then the technique that I will be using is robustness testing. What do you mean by robust? Robust is, see, even though in spite of giving the invalid inputs to your software product, it has to sustain strongly. Okay, it has to sustain the operation without failing or without any abnormal termination. Okay, after that, vulnerabilities means some abnormalities. Okay, vulnerable means you, purposely you are inducing certain errors. Okay, and you are testing out whether it works, it is performing as per the expectation or not. Okay, the testing technique that I'll be using is vulnerability testing. Whenever I'm dealing with the graphical user interface, the specified technique is GUI testing, graphical user interface testing. Okay, likewise, I have these things also with respect to reliability, system, customer, business, so on. As I've already mentioned, acceptance testing. It is basically dealt with respect to the customer's point of view. Okay, and performance also matters a lot. Performance testing, and you have so many examples they have given. If you remember one or two, it is more than enough, but the definition of this is more important. Understanding the definition, understanding the classes, categories is most important. After that, the last category that I have is artifact under test. As I've already mentioned, artifact is nothing but the material or the unit which is under the study. Suppose the application component is under the test. Okay, I have designed some component within my software by writing the code. Then that becomes the artifact which is under the study, which is under the testing process. Okay, then the technique that I will be using is component testing, single component testing. If the artifact is the characteristics is client and server thing, okay, then I'll be using client and server testing. If you are focusing more upon the compiler designing side of it, okay, you have designed some compiler and you are testing it, then the artifact which is under study is compiler, then the compiler testing. This is more easy. Okay, database, if it is there, then I'll be dealing with transaction flow, all the types of transactions. Okay, if it is object oriented software, okay, then object oriented testing is I'm going to perform. Likewise, they have listed out so many artifacts which we will be considering and for the testing purpose, and which all are the techniques that are dedicated for these artifacts. Okay, I hope everybody is understanding this. Okay, there are four categories basically you have to remember. The things which we are discussing is under the title types of testing. Four categories they have framed. One is based on the source of the requirements generation. Second one is about the life cycle phase in which the testing process is being carried out. Okay, and the third one, if you look out over here, okay, C1, C2, C3, C4, four types they have come up. Third one is about the objectives of this testing activity, and the fourth category is about the characteristics of the artifact which is under the test. I am going to consider one single material and I will be considering characteristics of that particular document or the component which is under study. Based on that, I am going to use certain techniques for testing purpose. So this is about types of testing. Okay. After that, I will be discussing about certain things called, these are not there actually, the predicates and all, it is not there for your syllabus, but I'll just take up one single example. How can we use predicates for writing the test cases? Okay, let me take up one example. Okay, Here there is a one simple example they have taken up. Okay, we are making use of predicates. You have, I think so, you have come across this predicate in discrete mathematical structure subject. Okay, how do we write the predicates? Okay, basically why we use predicates is for writing the test cases. Okay, and predicates arise from the requirements always. Okay, requirement is always the starting point. You have to remember. Okay, we'll just look into one small example here. See, it is a condition. Okay, I'm going to represent the condition in the form of predicate, which I'm also calling it as Boolean expression. Suppose consider this requirement. Whenever the printer is on and the paper is in the tray, then send the document to the printer. Means whenever you press on the print option in your screen, okay, what are the prerequisites? Paper should be there in the tray, as well as printer should be in the on status. Okay, it should be on and there should be paper in the tray. Then only particular instruction should be given to the printer to print that particular document. Okay, see here, this statement consists of condition and the action part. Okay, so they have written the predicate in this format. Printer status is equal to or, and this is and symbol. In discrete mathematical structures you might have studied this. And whenever printer tray is not empty, that means there are papers in the printer tray. This is how they have written the predicate. Now how can I generate the test cases from predicates? Okay, sorry. Now there are two techniques, BOR and BRO, for generating the test cases. Okay. So condition guard action, they have told if condition then action. This is a typical format always. That is functional requirements. Okay. How can I write predicates now? Okay. By making use of relational operators, Boolean operators and relational expressions. Okay. This is actually not there for your syllabus. Don't worry if you are not understanding this also. Just for your knowledge, I am telling you how they are used in the requirement. This part is most important. How I can write the predicate. Okay, by making use of logical operator as well as relational operators, I can come up with predicate. Predicates are basically used for test generation. Okay, test cases writing, I make use of predicates. Then they have also made use of Boolean expressions also, which is not there for your syllabus. Okay. After that, this is most important for part of your discussion for the day today. Program representation by making use of control flow graphs. In short, we will term it as CFG, that is control flow graphs. How can I build control flow graphs? Okay, see, always control flow graphs, they are composed of the basic blocks. Okay, and you have already drawn CFG. Okay, unknowingly I have drawn, but now I'll tell you whatever you have already done in the previous semesters. Okay, control flow graph, the name itself indicates you that, okay, this particular diagram tells you the sequence of the activities in which the control is getting transferred to different blocks in your code. Okay. I'm making use of control flow graph in order to indicate the transfer of control from one block to the next block based on certain condition. If it is sequential in nature, it will be step by step. If any conditions you have written, the flow of control will be different. Okay, so usually program consists of basic blocks in which I categorize the basic blocks. I'll identify two blocks among the basic blocks, one as unique entry point and one more as exit point. Okay, always your code is going to have one as entry point and one as the exit point. You cannot say my program is going to have two exit and entry point, then that is ambiguous. Okay, your code or the program written by you, okay, it enters a basic block at one entry point and it will come out of the program from by making use of one exit point. Okay, and there is no possibility of exit at any point inside the basic block. Okay, it has to come to the dedicated exit point only. Okay, dedicated exit point only. And entry and exit points of a basic block coincide whenever a block contains only one statement. Whenever your code is having one printf statement, suppose, then both entry and exit point is going to be the same. We will look into one simple example how they have drawn the control flow graph. See here, this is the pseudo code. This is not the program. This is the pseudo code. They are computing here x raised to y. Okay, x raised to y means the simple example 2 raised to 3. What should be the output? 8. Okay, they are computing this using this pseudo code. See, I have written begin and I have written end. Okay, there are three variables x, y, and the power, and one of the type float. Okay, I am going to input two variables x, values for x and values for y. If at all y value is less than 0, then power is going to be minus y. Otherwise, power is going to be the y value itself. Okay. And I have written the logic how to compute this x raised to y. Okay. This is simple. Everybody knows about writing a code for computation of x raised to y. How do you write? You already know it. The same logic they have implemented here. Let us represent this pseudocode by drawing control flow graph by writing the basic blocks. Okay, refer to this. Okay, this pseudocode you have to keep in mind, and they have specified certain basic blocks. Okay, see here, can you see this numbering? 1 2 3 4 up to 17 lines are there. Okay, see, they have identified certain basic blocks. Okay, it is left to you. Whenever you are identifying the basic blocks, you have to decide upon which all are the lines that will come under basic blocks. Suppose they have designed one basic block having the number as 1, and the lines which are included in the basic block number 1 is 2, 3, 4, 5. Okay, these four lines will be included in basic block number 1. And whenever you are identifying the blocks, please don't consider begin and end. That is line number 1 and the last line. You are not supposed to consider for the inclusion of in the blocks. You are not supposed to consider the first line as well as the last line. Okay, suppose the basic block number is 1. Which all are the lines they have considered? This is from line number 2 to line number 5. That is 2, 3, 4, 5 will come under basic block number 1. This is purely dependent on the programmer. Okay, you are not by this. Okay, it is left to you how you are making the classification. Okay, which all of the blocks you are identifying, how you are designing. Okay, it is dependent on the programmer. You are not supposed to stick how they have done. I will be doing like this only for another code also. No, it is programmer dependent. Okay, suppose here the block number 2, which is the line that is being included in block number 2, that is line number 6, and you have to go sequentially whenever you are identifying the blocks. Line number 6 is been added in block number 2. Then block number 3, okay, is having line number 8. See, why they have left this else part is this is just a keyword without any condition. Okay, else will not have any other condition, right? Simply it is a keyword, so don't consider it. Okay, it's of no use. If you consider also, it's no use. So they have left it, they have discarded it. So from line number 8, it is block number 3. Okay, after that, block number 4 is having one line, that is line number 9. Okay, then which all are relative in nature, related to each other, you combine those lines together. Okay, unrelated lines you can keep as single entity within the block. Okay, so after that block number 5. Okay, block number 5, if you come here, block number 5 is having the line number 10. Where is line number 10? Line number 10 is having while statement. Okay, it is separate only. After that, block number 6, it is having the line number 11 and 12. 11 and 12, they are interrelated because they are within the loop body. Body of the loop is consisting of these two statements. So I am combining 11 and 12 into a single block. That is, block number should be given here, block number 6. Okay, then block number 7 is having one statement, that is if statement, 14, line number 14. Then block number 8, again single statement, 15. Block number 9, 16 line number. And as I've already mentioned, don't consider begin and end and the lines having just a keyword without any condition. Such things should be discarded. So up to line number 16, I have categorized, I have put these lines in some of the blocks, and blocks should have numbers. Okay. Pertaining to this block, as I've already told, each block will have entry point as well as exit point. Okay. For this, okay, for this block, what is the entry point and what is the exit point? Okay. This actually it has to be see here, line number 1. They are telling line number 1 here. So even though it is not there, it has to be line number 2 here actually. Line number 2 is going to be the entry point and line number 5 is going to be the exit point. Okay. And if you come over here, second block, the lines that I've included is 6. As we have already known the fact that whenever a block is having a single statement, then entry and exit point will coincide. Coincide means entry point will be same as that of exit point. Since block number 2 is having a single line, 6, line number 6, then entry and exit point is going to be the same. That is line number 6 itself. Similarly for block number 3 and 4, 5 also. Okay. For block number 6, entry point is going to be line number 11 and exit point is going to be line number 12. Okay. And for block number 7, since it is consisting of single statement, here entry and exit point will coincide. Coincide means entry and exit point will remain the same. After that, it is applicable for block number 8 as well as block number 9. So first step is always the basic blocks design. Okay, and it should be in this format only. Whenever we'll tell you to draw the CFG, control flow graph, first step is always you come up with this block structure having 4 columns within it. This table should be constructed by you. Okay, and you have to mention those things. Okay, it is left to you. I've already told this is programmer dependent. Okay, you need not by heart these things. Okay, which all of the points have to add, is it as per the textbook? No, you have to know the logic how they have done. Based on that logic you do. Okay, take up any program and try to do the blocks, try to identify the blocks within the code. I'll give you one small assignment today. You have to come up with this table first, always basic blocks identification having the 4 column: block number, line number, entry point, exit point. Whenever you are designating entry and exit point, please see to that if it is having one statement, then entry and exit point will coincide. Otherwise, your initial line number will become the entry point and the last line number will be designated as exit point. Next step is about drawing the control flow graph. That is, in short, I call it as CFG. Whenever you come across the short form CFG, then immediately you have to guess that it is control flow graph. Okay, what do you mean by control flow graph? Okay, control flow graph, it is, I call it as G, that is graph G. It is defined as, it is a finite set, means it is countable in nature, having n number of nodes and e number of edges. You have studied in graph theory, I think so, or discrete mathematical structure. Whenever I'm giving definition for any graph, it has to start like this only. If we ask the definition for control flow graph, you have to explain like this, not in general terminology. It is defined as finite set n having n number of nodes and e number of edges. Okay, and how can I define edge? That is from point I to j. Okay, in E connects two nodes Ni and Nj in N. Okay, N is set of nodes, E is set of edges. Okay, and if any edge it is connecting from Ni to Nj, then I call it as an edge. Okay, and we often write G is equal to N comma E. N represent nodes, E represent edges to denote a flow graph G with nodes given by N and edges by E. So in short, what you are supposed to know is control flow graph G is defined as finite set of N nodes and E edges. That's it. Okay. And if you remember this, you write it. Otherwise, it's better if you write this much, it is more than enough. What you are supposed to know is G is equal to N comma E, where N represents set of nodes, E represents set of edges. That's it. Okay. Here, okay. Next come. We have studied, we have identified the basic blocks. Then how can I make use of these basic blocks in control flow graph? Okay. See here. In flow graph of a program, okay, each basic block becomes the node. Okay, and edges are basically used to indicate the flow of control between each blocks. That's why I've identified the basic blocks. Okay, that's why I've identified the basic blocks. Whenever you are drawing the CFG control flow graph, please remember that the node will be, okay, which all will be the nodes? The basic blocks that I have identified is going to be the node in your control flow graph, and the edges will represent the flow of control between the nodes from one node to the next node. Okay. After that, we also assume that there is a node labeled start and end, even though we are not considering start and end point while constructing the basic block. But whenever you are drawing the CFG control flow graph, you have to indicate starting point and ending point. Okay, and from starting point, for starting node, you don't have any incoming edge. Okay, because that is the initial point. You are not supposed to draw any edge for starting node. For ending node, there will be no outgoing edge. That is the common sense you should have. In the flow chart you have done already, start and end node. Okay, for starting point, there will be no incoming edge. For ending node, there will be no outgoing edge. This is the common sense you should have whenever you are drawing the control flow graph. Okay, they have taken up the same example here, okay, and they have drawn simple CFG control flow graph. Okay, that's why first step is always the identification of the basic blocks, because basic blocks will represent the nodes of your control flow graph. Okay, see here, N and E, I have already told G is equal to N comma E, where N is nodes, E is edges. Okay, here they have included start and end. Okay, in the conventions, when drawing CFG, you are supposed to write the start and end. Okay, how many blocks were there here? If you go back, okay, if you go back, if you can observe here, I'll just look into how many blocks are there. Totally there are 9 blocks. Totally there are 9 basic blocks, and these 9 basic blocks going to be your nodes in the control flow graph. So same 9 blocks they have written here. Okay, 1 to 9 preceded by start, and here it is ending with end node. Okay, start and end. After that, you also represent edge. Okay, you also represent edge. Here, from starting point, I am connecting to 1. That is basic block number 1. These are not line numbers. Please remember, these are basic blocks. These are basic blocks. Okay, from starting node, I am moving to the first block. Okay, from first block, I am moving to the second block. Okay, see here. You have to refer to this. Okay, you have to refer to this code. From first block, I am moving to the, from first block, I am moving to the second. Okay, after that, see, since it is having the conditional statements, if y is less than 0, let us go through the code only if you are not understanding. See here, line number 5 is been included in basic block number 1. So, block number 1 can be going to block number 2 if it is true. Otherwise, it also has the option for moving to the third block having the line number 8. If it is false, it turns out to be the false. Then I have to move to the line number 8. That is, I can move from block number 1 to block number 2, or block number 1 to block number 3. Okay. So same thing they have written over here. Block number 1 to block number 2, block number 1 to block number 3. If it is true, it moves to block number 2. If it is false, then it will move to block number 3. After that, which is the second block here? If you come over here, the second block is having the line number 6. Okay, where is line number 6? Here. Okay, after this, where the control should move on to? Will it move on to this lines? No, it will move on to this line. What is that? Line number 9. It is in the corresponding block number that you have to refer. That is block number 4. That's why they have written in the edges, okay, 2 comma 4. 2 comma 4. Based on this, okay, based on this you will draw this. Okay, based on this you will draw this. After that, okay, I have to take into consideration this block number 3 also. Okay, block number 3. Where is block number 3? Having the line number as 8. Which is that line number 8? Here. After this, it is a sequential execution. I have to come back to line number 9. So line number 9 is included in which block? That is fourth block. So third block should move on to the fourth block. That's why they have written in edges group. That is 3 comma 4. After 3 comma 4, I have to focus upon the block number 4, where it has to move to. What is block number 4? Block number 4 is having the line number as 9. After line number 9, I have to move on to line number 10 only, because it is sequential execution. Okay, that is block number 4 to block number 5. 4 comma 5. That is one edge I have to frame there. 4 comma 5. After 5, okay, what is that? Block number 6 is there. Okay, block number 5 is having the line number as 10. Okay, you have to refer to the program also here. Okay, here. After that, 11 and 12 are being